Hey folks, good morning. My name is Sunitha Kumar. I'm a Security Engagement Manager at Cisco and a technical lead. I work with the Security and Trust Office, and I'm here to present. I'm here to present the IoT, the future of IoT, as well as what the issues are today and where we are heading towards to get to embed security as well as privacy integrity within the IoT model itself. So thank you for attending the talk. I have uploaded the slides and I will go through the slides so that way you folks can follow it and do ask for questions whenever, and I'll try to pause in between. All right, thank you. So IoT that we know today contains a lot of embedded devices. And as you folks know, I know most of you are not new to IoT. So it's essentially having interconnectivity between every devices around you. So which is your phones, your wearable devices, your transportation, automobile industry, anything that is connected to the internet. So essentially your smart homes, your smart cities, so essentially anything that has an internet address, an IP address could be connected together. And that is what encompasses Internet of Things today. Now let's see what the messages are that take place between these devices or between these devices and a control center. I'm following slide 1. So if you look at the picture there, what we see is for every IoT device, there is a response request going between the central cloud and the IoT device, which in turn helps the IoT device learn and respond and behave accordingly to what the control center has. Now let's take some use cases just to appreciate the importance given to the control center and where we see things getting added on to the control center, wherein the control center fails to scale, right? So if we look at the automobile or the transportation industry, one of the use cases for IoT would be a local train trying to pick up the passengers, and based on the number of tickets offered by the ticketing center at the station, the train can decide if it wants to stop at that station or continue and let a slower train pick up the passengers. So this is a live mechanism, a feedback mechanism being sent from the automobiles themselves to the control center or the ticketing center to the control center. So that's one of the messages and the feedback going back to the train, local train, whether it has to stop at that station or not. Now, if you look at some of the other use cases which help appreciate the complexity that is available, that is caused at the control station, you can take the example of a cargo ship carrying materials, and based on the number of materials that are still that are still existing, in the sense that are still fresh and available and ready to be consumed, because some of the times the materials do get destroyed during transit. So based on that mechanism, the cargo ship can message back into the control center saying, hey, this is my cargo load, and hence I would need this amount of road transportation to transport this information onto the warehouses. So again, you see there is a back and forth mechanism wherein the cargo ship is feeding something to the control center, to the central cloud, as you call it. And the central cloud is feeding back to all these other IoT applications and endpoints to say what it needs to do. So these use cases hopefully will help you appreciate the complexity that is being handled at the central cloud, which essentially would cause a choke point depending on where we're going. So what we see with all the research that's coming out in IoT is by 2020 we will have 20 billion IoT devices connected. Now you can imagine if this amount of control mechanism is fed into the central cloud and coming back into each of these end devices, it will just escalate exponentially. So now, the other thing that we also want to take care is security, privacy, and integrity. And again, as you see in IoT applications, these are being handled at a central entity or a proxy, so on, which gets all the messages from the endpoints, addresses it at the central cloud, and then distributes it to the other endpoints. So again, based on the proxy used, based on the central control mechanism that different industries use, there is going to be inconsistency in security, privacy, and integrity, right? So hopefully this helped you understand the complexity and the use cases that are coming in for us to look at this, for us to look at a solution for this going into close to 2020, where we will be supporting 20 billion and more. So this is the next slide, and this is called the IoT future. So stepping into the IoT future, what do we want to do? What are we already seeing that the industry is adopting? The industry is adopting a common infrastructure, and the infrastructure would be your basic 4 blocks. And again, this is just one of the solutions that the industry is seeing. There are many other. So one of the solutions which will help us with decentralizing the cloud control, which will help with bringing a unified security, privacy, integrity into the IoT mechanism, and to help scale the IoT infrastructure is blockchain. And when I say blockchain, it actually consists of a couple of components, and those being the network, the database, the consensus mechanism, and the blockchain itself. So let me go a little into what blockchain is so that you can appreciate where we're coming from. So blockchain was, and maybe I'll come back to this slide in a bit, but stepping on to the next one, what it would say is, blockchain is one of the technologies that came out of Bitcoin transaction. And Bitcoin transaction existed since 2008. This was a payment system and asset management system keyed in by Satoshi Nakamoto. Now keep in mind that there are a few folks who say Satoshi was not a real person, but it was a group of people who came together to bring a solution for asset management and payment system based on distributed ledger. So what we mean by this is every node that takes part in the transaction of the asset management, that is to move the asset from point A to point B, maintains a ledger or a transaction database. And we call this as a distributed ledger because it exists in every node. It is distributed. There is no central entity. Now, as you see, whenever we come up with a distributed solution, there are many use cases, including IoT, which we are diving deep into today. There are other use cases such as finance, supply chain, and enterprise IT, all of which are looking to see how they can distribute the complexity that they have. How can they distribute the cloud so as to get maximum security, privacy, and inbuilt in the infrastructure. Now, something else we coined in the last slide was also the consensus. Now, as you see packets moving between point A to point B, there has to be a mechanism for the nodes to agree upon which transaction is correct. So what they do is there is something called as consensus, where all these nodes have to decide and come up with one blockchain transaction to say, hey, this is the valid transaction, and hence I'm going to add it into my chain. And again, blockchain, since it is distributed, not one person controls it. So if we go back to our previous slide now, wherein we have called a network database consensus blockchain, we do see that through every node there is a blockchain database maintained, and the nodes participate in the consensus algorithm so as to add different blocks to their transaction. So with this in mind, what's our, how does our use case improve, correct? So what we see with having a distributed cloud is there is no one choke point. Every node in the transaction, in the path of the transaction, participates in keeping the asset transaction. In the case of an IoT device, it could be a message or a feedback mechanism. Every node participates. There is no one central entity which is making a decision. And again, all these nodes do have consensus algorithm built in, which help to decide which transaction they need to append into their database and take it further along. Now you can ask, how is security handled in this case? And what we see is security is built in within blockchain because every transaction that gets added, please take a look at the last slide. It will help us understand further on how the blocks are added. So the last slide talks about blockchain transaction, and essentially we need to understand this in order to come back and apply this to our IoT use cases. So when Alice, assume, sends a message to Bob, if you see the blue and green, those are new messages being added at every node. What it does is the blockchain itself allows the previous block to be appended, and it authenticates the previous block by forming a hash of the previous block, so that every transaction that passes through it always has a chain of transactions which get it back to the original transaction. So when Bob gets the transaction, the entire chain is validated, and only Bob has the encryption keys. So when Alice sends the message, she would have encrypted her original message with her PKI keys. So when Bob gets it, he has the PKI, the public key, and he's able to decrypt the message. But what has happened is, in between, there are all these intermediaries who have validated the transaction. So there is no one single entity which is validating, but every node in the system is validating it. Are there any questions so far? Or else I can talk a little bit about Bitcoins and where Bitcoins are headed, and also where how we can use the blockchain in IoT future. Okay, so we can move on. What I wanted to cover here was, how the Bitcoin came about, and in the Bitcoin transaction, there are something called as miners. So when we look at these nodes and we say, hey, they are participating in blockchain, they are providing a consensus algorithm. These are what are called as miners in Bitcoin terminology. And whenever a miner is able to bring about a blockchain transaction, they are awarded in terms of Bitcoin. Now, keep in mind, Bitcoin is alternate currency. It is recognized, and people are using this currency for quite a few transactions, including buying coffee from Starbucks. In my last slide, I've put this across. They're using this for online gaming, such as Zynga. Domino's, you can order your Domino's pizza using Bitcoins. Overstock, this is an online retail store. Again, you can use your Bitcoin. So Bitcoin is an alternate currency that some industry has adopted. What people are looking at is one mechanism, one technology within Bitcoin called as blockchain, which could be extrapolated to other use cases such as IoT and supply chain, as I mentioned before. Now, with just the miners, the consensus is obtained through proof of work. So again, there are many consensus algorithms, and if we had to take this back to IoT, which is again a few slides before, which says IoT future, we got to look at how to optimize consensus algorithms, how to optimize database. There is a big chain DB that has been coined in, and vendors are looking into how to store big data in a blockchain. This technology has got about almost 1 billion in funding today, so it is quite important and will be shaping a lot of future technologies. Again, I've called out network and database. Those are again something that has to be tailored towards the applications. Now that we've understood what blockchain is, what consensus is, database where it stores all those transactions, and the network, of course, for any IoT application which uses blockchain, they have to come up with specialized infrastructure so that they get to a distributed cloud, and they have a timing, because when you send a transaction, it has to be timed, and make sure that that it gets there in real time. So that's the network piece. The database piece, again, how do you store the big data in blockchain? Who are the players there? How can we get better so that we can store a lot of data associated with the asset? Consensus, again, these are this is the mechanism that is used for the nodes to understand and to pick a valid transaction. Again, this becomes important, and this has to be specialized for your IoT application. And blockchain again. So hopefully this gave you a good understanding of the infrastructure that's going to start coming in for IoT future, and how consensus and blockchain might be leveraged for this. I do have a few questions coming in. Let me try to answer those. Great. What do you regard as the most interesting use of the Internet of Things? Excellent. Almost everything. And coming from a security background, I think the wearables are going to be the most interesting and the most embedded item that has to be secure, coming from a security background. Some of the examples I can give you is the pacemaker. Now they're having an IoT in the pacemaker that goes into the heart, and it gives feedback to say, hey, my battery is going down, or I'm getting this feedback from the human body. So the wearables are going to be big. I see in the future that everything coming together, supply chain, working with IoT, working with the enterprise IT. That was the first question. What's the biggest risk do you feel is associated with the Internet of Things? Again, it's disparity in Internet of Things because every device has its own capacity, has its own CPU, RAM. So if we want to do communication between the two devices, unless having something central which can understand you, which can understand the devices, it's talking between apples and oranges. And that's one of the things that blockchain may help give a solution for, because the assets or the IoT devices are talking with each other directly. So that is what I think is the biggest risk. What one factor would most accelerate the benefits of the Internet of Things? I think it's already accelerated. Whether we want it or not, it is accelerated. Essentially, what we're seeing is smart homes. So if you count the number of devices you have at your home, irrespective of what you call as electronics today, like your toaster, like your dishwasher, I think it's already come out. I know Samsung had a dishwasher which was having an IoT on it. Amazon have these little IoT buttons. You press on it and it orders your laundry detergent automatically. So pretty much everything that you see around you, they are connected and they are putting up an IP address in it, which means there is no need to accelerate further, but it's already there. We have to step back and see, going into this acceleration, do we have the right privacy, security, integrity built in, so we're not disclosing our private data to some other proxy, unauthorized proxy. All right. What's the one piece of advice for a business leader interested in the Internet of Things? Business leader, I would think, try to get the players in the IoT, or rather, I would say, look at the most important solution that you want to bring in for the IoT space, because IoT space is big, it is huge. What we need to do is kind of step back and see, people are doing all of these things, but in the end, what are they not doing? They're not looking at scale, they're not looking at security, they're not looking at how do you make the endpoints communicate effectively when they have disparate processing speeds. So I think IoT as such, the use cases are plenty, but I think the infrastructure, there is no good solution for the infrastructure, and that is what I would give as an advice to the business leader. What are the trends you see coming for IoT technology in the next 6, 12, 18 months? Wow, this is big. I mean, in the 6, 12, 18 months, of course, all these new technologies people will start adopting. I think there is one place in my slide, let me see, the last one was BitShare. So apparently these guys are embedding blockchain chips. They're embedding chips which can start mining, which can do the operation that a single server can do. So instead of having a complete a server processing power doing your mining, it can be done by a single IoT device. So the next 6 months and 12 months, we'll see a lot of processing power being fed into the IoT devices itself, so that the requirement for a central entity will start getting lesser and lesser. So those will be the trends in the next 6, 12, 18 months that we'll be looking at. What are you most looking forward to in the future of IoT? IoT, I would want it to be secure, because all our data are going to be flowing across many devices, and they'll be controlling how we live, right? If you take the example of the pacemaker, you want the communication to that to be secure and private, because you don't want you don't want to stop living because something went wrong with pacemaker. So I'm looking at somebody, I mean, people are already doing this. I'm looking at the solutions coming together from the industry to get a solid foundation for IoT privacy and security. That is going to be a big player. The next one was, how will we pay for the IoT? Well, I don't think they'll be going through the model of paying for IoT. They will feed in IoT devices to our homes and cities, and they will try to grab as much information from there. And the model of IoT would be, what they do with that information. They will start feeding it to other channels, and that is going to be the monetizing. That is where they'll be getting their monetary benefits. So for the consumer, I think IoT is going to be free, but what they do with the data they get, that's when they're going to be monetizing. And that makes it more important to figure out what data goes out from us. How do you explain IoT to someone who has absolutely no idea what it is? Show them a smart watch. Or show them in Brazil, or was it Brazil, no, in Spain, there are these garbage cans, and they have IoT in it, and apparently they communicate to their back-end office to say, hey, I'm full. So that is an IoT. So just get them regular daily examples to say, we had to go and open the garbage can to see if it was full, but now not needed. As soon as it's full, the truck comes and picks it up. So it is more automated rather than what we thought had to have a manual intervention. So use cases are your best friend to get them onto IoT. What effects will the Internet of Things have on our daily lives? I think I went through this. It'll have quite a lot of impact. What will happen in terms of job losses and skills as IoT makes devices? I don't think we will lose jobs. There will be more jobs, but it'll be in the area of analyzing the data. Data sciences is getting big. So essentially, people will see how to correlate data. I'm getting data from your smartphone or your smartwatch. I'm getting data from what you bought today, maybe Starbucks or somewhere else where you used your wallet. Maybe you did a Bitcoin transaction. So I'm going to take all that data and feed in and give it to my data sciences and big data, and they're going to analyze and give me more information that I can feed back to my customer and say, hey, because you had Starbucks and because your body temperature or your heart rate is so much, blah, 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 this is what you got to do. So I think we will not have a dearth of jobs. We'll have a different set of jobs, I think. What difference can governments make to ensure IoT will be safe and secure and there is a serious potential threats to governments and states? Absolutely. What we see today is funded government attacks, the one we saw on Sony, the one we saw in a few other places, which they said came from different governments. Again, it is a hard one. It's as good as saying, hey, we don't want any IoT devices because we haven't figured out the security behind it. I would say every consumer owns their own security and privacy, and when you pick up an IoT device, make sure you understand what security, what configuration they have fed in, what is the default configuration, where are you feeding your information to, and I think that will help where we want to take the the IoT market into. Because if every customer, every consumer comes and tells them, hey, I need to understand what you built in this before I can even buy it, that will help the consumers take back and say, yeah, we got to look at this and build it then. And I think that's going back into the same government question, that whatever they bring in, if they are putting a smart city in place, they need to understand who else will get that information. How many governments can look and see, the population in the city, or what the population is doing. So it does become a potential threat, and it is important for the government to understand that. And I think the players in the IoT today, there are people from NSA as well as IT and technology. So they're working hand in hand in the space. I think those were the IoT questions, folks. There was one last one which says, tell us a little bit about what you do and how you got into your career field. Sure. So I am a security engagement manager and a technical lead at Cisco. I work at the Security and Trust Office. Now, this is a space that is very close to my heart, as I am passionate about security. I have been working in security for the last 20 years, just developing different products. So I was a builder and a breaker in terms of security. So I built a lot of products for the last 20 years, spanning into voice over IP, virtualization, networking, and each of those pieces had a security part to it. And since I was more passionate into security, I would pick up and start working in those areas. Although it is product development, it is more so focused on getting a security component into the product. And in this last 1 or 2 years, I've been more in the influencing role, wherein I look at all the gaps, the security gaps that come in the different products within my company, and give them a plan, a remediation plan, show them the risks, because none of the products are 100% secure. So we got to take that into perspective and give them a plan, so that they understand the risks that would occur on the product, and they eventually put a mitigation plan. So that is what my role is. Was there any other questions? What did you study in school? So I did a bachelor's in information technology, and I did a master's in computer engineering. This was, of course, eons ago. And if you are interested in any area in computers, it is good to have a computer science or a computer engineering background, just because it kind of helps you understand the bigger picture. By knowing the smaller picture, it's always good to have that in perspective before we try to understand the bigger initiatives. Was there any other question? What advice would you give to someone looking to get into the IoT field? I would say look for, if you're already in a company, look for these stretch assignments that most of the companies have, and try to understand the business units in your company that do have a play in IoT. some of them within my company, I know there was a smart grid, there was a smart car initiative, a couple of new security initiatives that are coming in, which all feed into IoT. So I would say try to understand the players in your company who are working on IoT, and reach out to them asking for a stretch assignment or an assignment that you can work along with them to just try to understand what they're doing. And eventually, if they think you have something that they might leverage, maybe you're good in coding, for instance, and they need some kind of code for IoT, you will get absorbed there. So start understanding those players in your company and start connecting. So that's the biggest advice I would give. Just keep 15% of your time over whatever else you're doing. 15% of your time you're giving for networking, right? So you would go and try to connect with people. If there is an IoT forum, you would have to show up there, connect with people, understand what they're doing, and that's going to be your first link getting into IoT. Anything else, folks? Okay, so let's actually wrap up since we have a few questions answered. Let's see. Okay, so I would like to take you through the last slide, which is conclusion for this topic. What we're saying is blockchain is going to be a big player that will shape the future of IoT. So even if certain IoT space excuse me, has not adopted blockchain, it will eventually because of the inbuilt security, privacy, integrity that it is bringing in, and because of the number of investment that has gone into this technology. It's been close to 1 billion, as I mentioned in my previous slides. Specialized infrastructure will cater for IoT based on what solutions they want to bring in. Security, privacy, and integrity will be built in, and because that's where, as you folks also asked in the questions, that's where the major the major gap is in IoT. So we will see distributed cloud rather than a central cloud, wherein the processing is distributed between every node and maybe even through the devices themselves. Some of the references you could look at for this is the IoT environment. Ethereum, they're coming up with a cloud which caters to IoT applications. This is open source, so you can actually build your APIs around it. The other one is BitShare, which is where they're embedding mining capability in every IoT device. So those are some cutting edge technology that you could further reference if the topic interests you. All right, folks, thank you for attending my talk.